L and M sub L. Okay, so now that I hope you're not completely confused, we're going to go on to talk a little bit about the values these guys can have. So if we're in the first shell, this part is pretty good. 1 for N is the first shell, okay, or the first energy level. Or we could say the principal quantum number is equal to 1. N equals 1. If N equals 2, we're in the second shell, which is, of course, the same thing as saying you're in the second energy level. They're synonyms. And again, for 3, we're in the third shell, would be the third energy level, on and on and on. So it's not hard to decide what N is. If you're in the first shell or first energy level, you're 1. If you're second, you're 2. Then it gets a little more complicated. So let's go on to a little more complicated one. L. The values of L can be 0, 1, 2, 3, and actually it can go on and on because there are others that we don't even know, that we don't actually usually use. The 0 value for L is the S subshell. So anytime L is 0, we're in an S subshell or an S sublevel, whichever way you want to say it. When L is 1, you're in the P subshell, which is, of course, the same thing as the P sublevel. If L equals 2, you're in the D. If L equals 3, you're in the F. And if L equals 4, you're in the G, because now these are the ones that are actually occupied at ground state, the SPDF. From G on up, 4, 5, 6, 7, 8, 9, 10, whatever, all of those start to go alphabetically at this point, G, H, I, J, K, but they are only at excited states when we've given an electron a whole bunch of extra energy. That's when it can jump up to a higher sublevel. So S, P, and D and F are really all we need for describing atoms in their ground state. Okay, now we said that L is the shape. So I would refer you to your textbook to look at the shapes of these orbitals. And so the shape of the S orbitals is described on, let's see here, page, I guess there's several different pictures of it, but let's say page 233 is a good one. It's just basically a sphere, okay? And it's pretty easy. And then we want to look at the shapes of the p orbitals, 238 and 239 for the Fs, okay? For the Ds, sorry, for the Ds. And do we have some Fs on this page here? No, we're just showing how they combine. The Fs, it doesn't even bother to show you in your textbook. I'm kind of surprised by that, but they are much more complex yet. So instead of 2 lobes like the P or 4 lobes like the D, we got 8 lobes, or we got things with a couple donuts around their middles, and it's just they're very complicated shapes. So you can Google them if you want to see them. That's the shapes. So on to the next one, M sub L, and that's our last one. Aren't you glad? So if we look at when L equals 0, then M sub L equals 0. Yeah, it's not so bad. Okay, when L equals 1, then M sub L equals 1 or 0 or -1. There's 3 options for when L equals 1. So let's correspond that back up to the one right before it. When L equals 0, what's our subshell? It's an S subshell. Okay, so an S subshell, remember the picture was a sphere. There's only one way to orient a sphere in space, so you only get one orbital. When we get to the L equals 1, then look up at the L's. When L equals 1, we're in a p subshell. Okay, we have 3 different p orbitals. One along the x-axis, one along the y-axis, one along the z-axis. And in fact, sometimes they're called px, py, and pz to show that. Okay. When L equals 2, then m sub L can equal 2, or 1, or 0, or -1, or -2. You get the idea? It can go anywhere from L, whatever L equals, in this case L equals 2. It can go from 2 down to negative whatever L equals. From 2 to -2. Only integer values. No fractions, no decimals, no nothing. Okay. All right, so when L equals 3, then m sub L would be what? Anywhere from 3 to -3, and of course only the integer values. So here are the possibilities: 3, 2, 1, 0, -1, -2, and -3. So now when we count these, we can see that for L equals 0, remember that's the S subshell. How many orbitals are there in an S subshell? Well, look at m sub L. There's only one. There's only one value. M sub L is 0. There's only one value there. So there can only be one orbital. When we're in the P subshell, that means L equals 1, right? Look up above at P equals 1. Then down at m sub L, if L equals 1, m sub L equals 1, 0, or -1. 3 orbitals. When L equals 2, what does that mean? 2, look up above, that means the D's, right? So we then look down, and when at the m sub L, when L equals 2, m sub L is 2, or 1, or 0, or -1, or -2. One thing that's really nice is that kind of corresponds, in fact it exactly corresponds to our periodic table, where we have the S part of the periodic table, the P part of the periodic table, the D part of the periodic table, and down here the F part of the periodic table. If you look at the number of orbitals, and you know that an orbital can hold maximum 2 electrons, right? Well, look at the S. The S is, the whole S section is 2 boxes or 2 columns wide. 2 electrons, 1 orbital. Okay, let's go on. The P section of the periodic table is some lines there. Okay, 6 columns wide, right? So 6 electrons can go into the P subshell. Well, if 2 electrons go in each orbital and 6 electrons can go in, then we probably need 3 orbitals, because 6 divided by 2 is 3. Oh, look, we have 3 orbitals right here. The D section of the periodic table, 1, 2, 3, 4, there we go, is divided into 10 columns. And so that would mean we need 5 orbitals. 10 divided by 2 is 5, because 2 electrons go in each orbital. And look, indeed, we have 5 orbitals. And then this, of course, L equals 3 is the F's. M sub L equals 3 from there's 7 of them, right? So we have 14 here. I didn't make those very even, but anyway, there's 14 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I need another one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyway, there's 14 boxes going across the F area of the periodic table. 14 divided by 2 is 7, so we need 7 orbitals. There we are. That works. Somehow it all fits together. So you might need to listen to this a couple of times, compare the pictures in the book, and compare the filling chart for the orbitals. And we will work more on this in the next chapter. So if you don't have the whole filling business in there, that's okay at this point. What you need to do is just kind of understand the relationship of these numbers and the variable names, and what's allowed and what isn't.